Hello friends, welcome back to your UPSC. So today we'll start with another topic of geomorphology, that is denudation chronology. So let's get started. So denudation chronology is exactly a reconstruction of denudational history of any given region. Denudation means it involves the process of erosion and weathering. Okay? So denudation involves erosion and weathering, and it is related to time period. Okay, so reconstruction of denudational history, so chronology is based on time period. Okay, so hence we can say that denudation chronology is the process of erosion and weathering over a period of time. Okay, next, the approaches to denudation chronology. Now we will basically see in approaches of chronology, we'll study about aim of denudation chronology, what it tries to understand by with denudation chronology, what we try to understand. Next is assumption of denudational chronology and its major weaknesses. So denudational chronology actually aims to understand the landform evolution with respect to geological timescale, that how within a given period of time or with the time the landscape is formed. Okay, so next is assumption. So there are basic assumptions in denudational chronology. The first assumption is there is a sequential change in landform that occurs over a period of time. So the change in the landforms occur in sequence. It don't occur drastically. It occurs in sequence over a period of time. Next is plimsoll topography. Plimsoll topography is actually, I'll give you an example. Like I have written something here. Now I will erase it. Okay. So we will see that sometimes some imprints of the whatever I have written, some imprints will be left. And I will write another thing here. So the same is with plimsoll topography. The surface bearing geomorphological imprint of the past geological period, after practically being erased, initially imprint in the beginning. Okay, so there was first one geomorphological feature that has been erased, and another geomorphological feature is formed. Okay, but there are imprints of the previous one. Okay, so that is known as plimsoll topography. And the last assumption is reconstruction of geological history can be done on the basis of present study. So we can only reconstruct the geological history by looking at the present state of that topography. Okay, so if we can see there is a plain surface having some hilly features, okay, some hills, we can say that it was a mountain once, like Aravali. We can say that it was a great mountain, but now due to erosion or due to denudational processes, it has lowered its height. Okay, next we will look into the weaknesses of denudational chronology. So there are three assumptions and we have three weaknesses. The first weakness is highly deductive. So we can't foresee the event. Okay, we don't know about the future of this event. So all the responses are described on the basis of limited information and evidences that we have. Like this thing has happened to this one. So it might be that this landform existing in this area will also experience this type of erosion or denudation, so that we can just uh, deduct deduce, but we don't have any full proof. Okay, full proof evidence that we can just 100 we are just 100% confirmed that this topography will only be formed, so our future event is not seen. Next, see, in plate tectonics what happens is there is whole world is explained, like how the folded mountains are formed, how the sea floor is spreading due to plate tectonics. So the global study is done in plate tectonics. While in this denudational chronology, only a small part of the existing landscape is studied. That is local, it is locally studied. Like this area is having this type of climatic conditions, and here this type of erosional agents are present, so this topography will be formed. So this is not happening in plate tectonics study about global event, but this denudation chronology, it studies about local event. Now next is dating erosional surfaces is highly speculative, so we can just speculate that how old this surface may be, but because we don't have valid geological evidences. Okay. Now, as we have done denudational chronology, now we will jump over to erosional surfaces. Erosional surfaces are plain topography or almost plain topographical surfaces having undulating ground surface and remnant of low reliefs caused due to dynamic wheel of denudation process cutting across the geological formation and structure. So like this is a mountain. Okay. It has converted into plain with like some Monrock features. Okay, so there these are some undulating ground surfaces, and it is almost plain topographical surface now. And how this has happened? It has happened due to denudational process in which the area is the area is cut, okay, cut down by the erosional or weathering agents. They form significant, like erosional surfaces form significant element of landscape of given region and provide predominant clues for reconstruction of denudational chronology of that region. So after looking into the erosional surface, we can speculate about how the denudational chronology in that area has taken place. Now, as we know that erosional surfaces, identification of erosional surfaces and speculating about them is not so easy, but scientists have tried to do it, and they have, like, till some extent they have succeeded. So there are few identifications which we can see in erosional surfaces. So the first identification is, like, when you see a landscape or an erosional land surface on the basis of its modification, like if it has modified more, then it is a older surface, and if it has modified less, like it is in its almost it is in its original form, then it is a newer landscape. Okay, so why? Because the erosional agents or the weathering agent or denudational agents have worked more on this surface because of because it existed more much before this one. Okay, so the more modified one is older and the less modified one is newer. Second one is erosional surfaces have been uplifted. See, all the erosional surfaces have been uplifted, but if and we can't see, or it is like very rare that we can see any erosional surface near the ground sea floor level. And if we can see any such surface near the sea floor level, then we can just clearly say that it is due to subsidence due to tectonic movement. Okay, now the next is erosional surfaces younger than tertiary era. See, we can't find any erosional surface, totally erosional surface, fully erosional surface, which is younger than tertiary era. That is, post tertiary era, we can't find any of the erosional surfaces, but partial erosional surfaces may occur or might occur. Okay. Now the next one is two erosional surfaces having same height. See, there are two erosional surfaces in same area having same height and same structure. Okay. But their rock structure is different. So this is having a hard rock structure and this is having a soft rock structure. Okay. So this one is older and this one is newer. Why this one is older? Because they are having same type of structure. Okay, only their rock structure is different, their structure is same, their height is same. So this one has been eroded more because of agents over a long period of time. Sorry, over so this has been eroded over a long period of time, and because this is hard, so the might erosion have taken time in this one as compared to this one. Okay, now next one is the relatively younger surfaces formed on resistant rock. Okay, so the relatively younger surfaces are formed on resistant rock, and they are actually in the form of plateau. Okay, having a flat top and accordant height. Okay, now we will see how can we date the erosional surfaces. Now we will study the dating of erosional surfaces. So dating of erosional surfaces can be done by four methods. So the first method is radiocarbon dating. Next is interpretation of sequence of sedimentation. Third one is height of correlation method, and the fourth is geological unconformity. So first we'll study geological unconformity. Geological unconformity is basically gap in geological record or a break in sedimentary behavior of a rock. See, what happens is there is a rock structure. So this is our top rock structure. But if we go down, we see that the rock structure is like this, like having a different characteristic. So this rock structure and this rock structure are having altogether different characteristics. So we can say that there is a break or a gap in the geological record, and this gap is known as unconformity. So unconformity can be basically of four types. So we can classify unconformity on the basis of their structure on four types. So the first unconformity is disconformity. Second one is non-conformity. Third one is angular unconformity, and fourth one is unconformity. So the first is disconformity. So the disconformity means there is a gap in geological record that separates two different kind of sedimentary rocks or similar type of rocks seen in an area having drastic topographic changes. So this is the diagram. These both are sedimentary rocks, but they are having different type. They are of different type. Okay. So like this one is of different type, and this one is of different type, formed from a different rock, and this one is formed from different rock. So this is known as disconformity, in which same rock type but same rock but of different type. Okay, next is non-conformity. Non-conformity is rock of different type in a region. See here, what happens is there was in the disconformity we have seen that there are same rocks but of different type, but there in this non-conformity there is altogether two different type of rock. So we can say that here first one is sedimentary rock, and the downward is down one is metamorphic or igneous rock. So there is clear division on land surface. Clear division can be seen on land surface, demarcating a break. Okay. Next is angular unconformity. Angular unconformity is there is different pattern of rock deposition. Okay. So in this, what happens is, see, previously there was a mountain. Okay, this mountain starts to denude, so it has denuded. Now what will happen is, this is the lower surface, and now on the top of this surface deposition will start, but this deposition will be in different pattern. So this deposition was tilted, and this deposition is flat deposition. Okay, so there are, we can see there is different pattern of deposition. The upper one is flat and the lower one is folded. So this type of unconformity is known as angular unconformity. So, and last one is para unconformity. In para unconformity, it is not exactly a sort of unconformity. That's why it is known as non-depositional or pseudo unconformity. Okay. Now, this was dating of erosional surfaces on the basis of geological unconformity. Next, we will see dating of erosional surfaces on the basis of radioactive dating. So, radioactive dating is done on the basis of carbon emission. Okay, so radiocarbon dating. So, here we can find the absolute, or we can determine the absolute age of the erosional surfaces, but here one condition is implied, that the erosional surface should be organic. Okay, so only organic surfaces can give radiocarbon, only on organic surfaces we can do radiocarbon dating. Okay, so after the life on the earth started, before that, whatever the erosional surfaces were there, we can't determine their age from radiocarbon dating. Next is interpretation of sequence of sedimentation. Now what happens in this one is, see, there was a mountain, okay, and there is a low-lying area. This mountain started denuding, and this denuded particles, they started to deposit on this low-lying area. So we will see that in this low-lying area, what will happen is, the topmost part will be having finer particles, okay, and as we go down we will see the porous particles, or the pebbles, boulders, etc., at the lower area. So according to this, we can find, or we can date the erosional surface. And the last one is height correlation method. Height correlation method, it involves inclusion and consideration of all the remnant of the surface having accordant summit level. Okay, so that was height correlation method. So with this we have completed dating of erosional surfaces. So that was all for today, guys. I hope you enjoyed the lecture. So let's meet in our next class. Till then, take care and have a nice day.